So in the last lab, in lab 9, what we did is we created our external table. We have it so we can pull data from our transaction upload table. We also built the transaction table. Well, in lab 10, what we're going to do is we're actually going to take the data from that transaction upload table, and we're going to pull that data into our system. Now, the tricky part is really all we're going to do in lab 10 is write our select statements. We just want to kind of like what we did in lab 7. You remember where we did the select with all those crazy case statements because we wanted to insert in a price. Well, we're going to do the same thing, but this time we're going to pull it out of transaction upload. But the big asterisk to this is, so the first one we can write the select statement, but the second one relies on the data that we have inserted into the first one. So we're not only writing the select statements, but we're going to insert the data too. But the weird thing about lab 10 is this is all just a preparation lab. So when we finish lab 10, we're going to go to lab 11. In lab 11, we're going to use what we do here in lab 10. But lab 11 will actually call straight to lab 9. So lab 10 is just kind of like this. Let's just get a brunt of the work out of the way so that way we have it for lab 11. We're actually not going to use lab 11 all that much. Now, when we're working on lab 10, we're going to not be using lab 10 all that much. When we're working on lab 10, we actually are going to want to call all of our previous scripts because the one downside is that lab 10 is not going to be rerunnable, meaning that, if we were to run it multiple times, we're going to duplicate our data. And we're going to fix that in lab 11, but for lab 10, we're just working on getting the data that we want for a future, what is called a merge statement, which we'll cover next week. So anyways, let's jump right into some of these instructions. So lab 10, the first thing we're going to do is we're going to write a select statement. And it talks about a mapping and translation table. And this mapping translation table, what they're referring to is basically we want to know where the data comes from and where it goes, which we will talk a lot about. I'm going to put that in there so we have it. Yeah, so we're gonna talk a lot about where the data goes, and that's kind of like what we're gonna do in this this video today. Is we're really gonna just talk about where the data is coming from and where it's going, and hopefully along the way, you can kind of see how you would go about doing this if you didn't know, because we're gonna do a couple examples, but there should still be some left to do. So hopefully, you'll actually see kind of how it's done, how you would go about doing it. For the most part, it's pretty common sense. So, and I think it tells you a lot, actually. Okay, so we're going to do it on the mapping table. This step requires you to create a query that takes records from the transaction upload table and inserts them into rental. And really, this our main focus is the select statement. But we're going to also do the insert because we have to insert into rental to then query rental item. So we're going to do the rental item, and then transaction. All right. And you can, this gives you the select list and format column in your query. So I'm actually going to skip this for right now. And I'm just going to pull this right here. That gives you a nice place to start on. All right, so let's come over here. And we're going to insert our step 1 statements there. So let's do this. Now, obviously, so this is our select list, right? And if we were to pull up, so let's describe rental. If we were to pull this up, just like we did in lab 7, these are going to directly correlate across right here. So for example, rental ID, Contact ID is the customer ID. Checkout date, return date, created by, creation date, last updated by, last update date. Now what I'm actually going to do is I'm going to take and I'm going to put as customer ID right here. So it makes sense because that way they're all the same. So now what we need to do is we need to build our clause, our from clause. We need to build our from clause and our where clause and all that. And he gives you this nice starting place, and we're going to talk a little bit about it. So you'll notice that here he gives you, it says naturally you can't start with that select list because it refers to columns not yet in the result set. But you can begin with this step with the following base query. So this gives you actually a really good starting place. And this one over here, this is going to be your select list. So usually what I like to do, because I do the same thing, I like to run, and I think I've said this before, I like to do joins at a time, right? So I like to do my select and with the bare minimum and then build joins at a time. Well, he gives you this nice little base query, which has member join to transaction upload and then join to contact. So this is really nice because it takes a lot of the brunt work out of it for us because we have this now. A little bit of troubleshooting because a lot of people, this is where it might cause some issues. And I remember saying this in Lab 6. I remember saying, make sure you watch Lily Luna's Potter's middle name because this is where it's a big deal. Because we don't have any keys to connect contact to transaction upload, the only thing that we have as far as contact to transaction upload to effectively identify whose record that is first, middle, and last name, which is terrible practice, but this is an exercise. And so here you can see that we're joining contact to member, and then so we do all of our joins from member to transaction upload based on the account number. So like a family like the Potters at this point, they're all connected to their accounts, but we don't know who rented what. So then we join to contact from member M to contact C member ID, but that still doesn't tell us who rented what because we simply just connected to member and they all have the same account numbers. So then we have to filter. So we say where the first name is equal to the first name, middle name is equal to the middle name, and last name is equal to the last name. Well, like we've talked about before, if your middle name's null, we have to have some way to evaluate that. So we use this null value function. And if the middle name is null, it turns into an X. And so if X equals X, it's true. So if they're both null, they'll both be X. If they both have a value, hopefully they match. So if you're not getting like some rows here, I would definitely check Lily Luna Potter because I think she's the only one with a middle name. Check the middle names because that's where this could go wrong. So what I like to do is let's give this a run. And there we go. So we got 7 rows selected, 7 contacts. And I'm actually not correct because if you notice here on the instructions, it says that it should return 15. And I'm not quite sure what's going on. So let's select everything from contact and see. But first, let's set our line size. All right, so it looks like we got our Potters. And I'm sure that it's probably something to do with and I don't know if it's probably something to do with Lab 6. Let's go back here. Make sure we're running here. Everything's good. Anyways, there's probably something somewhere that's making it so I don't get it. But we're gonna pretend for a minute. And yep, okay. I need to run lab 9, so let's do that real quick. So you should get 15 rows here, which is basically one for all of your contacts based on their account numbers. And so maybe one of my account numbers is messed up because really that should just be, that should just be the account numbers, which is very possible. You know what, let's check real quick. So if I were to change this, but instead of contact, we're going to select contact ID and account number. Let's give this a shot and see what we get and see if we're and let's also add their last name. And then we'll know who the problems are. Right, so this is kind of nice because you can kind of see what's going on here. Oh, and now I get 15 rows. So yeah, I don't know what happened there. Maybe I didn't run it right the first time. I don't know, but I'm getting 15 now. So that's what matters. Oh, it was the account numbers. No, that was still right because we were getting contact ID before. Anyways, it's working. I probably just didn't run the right lab or something, but it's working now. We've got our 15 rows selected, just like we should. If you need to troubleshoot though, feel free to add some of those columns like I did, because then you can help troubleshoot. Because let's say the potters were missing, we would know right where to look. Or if just one potter was missing, we would know that it's just the one. So anyways, let's go back to our base query here like we have it, and let's look at our instruction details here, because this is going to tell you a lot of what to do. So it says in the first step of the lab, you will complete the from clause by providing all the necessary join statements. You should write join statements with inner join, left join, or right join operations. And then you insert the result as rows into the rental table. So a lot of this is already done for us. So it says like join the member table to contact table with an inner join with member ID, which we do right there. So it's a little backwards from what they give you up there. And then it says join the foregoing result set, which is a result set of the join between member and contact, to the transaction upload table, which is what we do. We actually go from member to transaction upload, but we could swap that pretty easily, but it's already here for us. So we know that these two bullets are done. And then here's the big one, right? So now it says join the foregoing result set to the rental table with a left join. So this is where we're going to start writing our code now. So we're going to join it with a left join. So we're going to take this right here, and we are going to go right here, and we are going to add, oh, hi. Sorry, my daughter just came in. Just a minute. We're going to do a left join here to rental. So we're going to say left join rental, and we're going to call that R. And we're going to use our on clause. You should match the contact ID column of the contact table with the customer ID column in the rental table. So that gives us a really nice idea of what we're looking at here. So then we're going to say c.contact ID of the contact table equal to the customer ID of the rental table. Now here's another one, because we're actually going to have two. So it says and the truncated checkout date and truncated return date from the transaction upload and rental table. So we're going to add another one. So we're going to say and. We're going to say, because we already have transaction upload, so we're going to say transaction upload, but we want it truncated. So let's go trunc tu dot checkout date equals trunc r dot checkout date. And then we're going to do one more with the trunc tu dot return date is equal to the truncated r dot return date. Now, one thing that I want to point out here is why we're doing this. Okay, so what we're doing is before we have all of our member to contact to transaction upload. So basically we have all the transactions organized by the account number and the contact. Well, we want to be able to connect this to rental, right? Because if you remember, right, our business scenario is that we have our POS system that's, tracking all these transactions and the rentals. And then we have our database that we're building that's going to, store this long term. Well, the problem is we connected it with our contacts and stuff, but we needed a way to have it connect to rental in a way that it would show even if there wasn't an existing row. Like for example, contact, if there was a missing contact in our table, it wouldn't show up at all because of the inner join, right? The inner join means that it only has the ones where they intersect in the middle. Let's pull that up real quick. Let's do SQL joins. Right, so this is our inner join, and this is transaction upload, this is contact. It's only going to pull results in the middle. Well, these are all new rentals, right? Because we have all of our memberships and contacts and stuff like that, but our rentals are all new, right? We don't have 15,000 rentals in our database or however many there ends up to be. So what we want is if table A is transaction upload, we want to select those even if there's not a join in rental, right? So in this case, they're either going to have a match or they're going to be new, which is exactly what we want. So, and we do that, we can basically specify what rental it is based on the checkout date and return date. So let's try running this. And we're still got our 15 rows. What's nice is we run it, and if we still get our result, then we know we're on the right track. Now, what I'm going to do is I'm going to take and I'm going to replace my top section here with this. So I'm going to take this one from previous that we said we were going to do, and I'm going to put it right there. I'm actually going to delete this now. And now let's run this. And there we go. And I get 4,681 rows selected, just like we should. And that's the most important thing, is that you have, your data in the right place and all that. So what this is this is actually a perfect, I guess, replica of the rental table that we would normally see. So I'm actually going to paste this in here again now that I've got it. So this is our rental items, our rental records that we're going to insert. So now that we have and this is really what we came here for. So if we didn't care about writing step 2, we could just be done. But step 2, we need to have these rows that we just queried from transaction upload into rentals. So now we're going to actually do the insert for those. And the nice thing is the inserts are probably the easiest part of all this, because we just get to kind of put a little wrapper around it. and then paste our select statement because we have all of our data here. And we did this in lab 8. The lab 8 step 1 is the first time we really did this because we took our query from lab 7 and we inserted it into price. So what we're going to do is we're going to, and let's do this. We're going to say select count of everything from rental at count of everything as count before. Right, and I'm going to put this in here just so we can see what it is. So like right now, our count before is 7. Well, then what I'm going to do is I'm going to write my insert statement. So I'm going to say insert into rental, right? And just like our one before, we kind of have to do this little temporary query here because we're gonna check. So the first thing that we need to do to insert into rental, let's do our describe on rental again, is all of our columns. So we need rental ID. And why am I not scrolling? There we go. So we need rental ID. And where do we get rental ID? Well, we get rental ID from our, if we look at our query here, rental ID right there. But the problem with rental ID is that if we look at our results, let's get a, well, I'll just tell you, it's null. And a lot of those, right? Because we only had 7 rentals. So 7 of these rows are going to have a value and 7 are going to be null. So like what we did with price is we said rental dot underscore s1 dot next val, right? We used our sequence. But the problem is this isn't going to work because some of these already have values. So what we're going to do is we are going to instead use null value function to basically say if it's empty. So we're going to say, look, if rental ID is empty, meaning that it's a new row from transaction upload, then we want to use rental s1.nextVal. Otherwise, it will be the rental ID as rental ID. Let's make this a little prettier. All right, the next thing we have is our customer ID, which we are going to get from our query. So and I'm going to call our query R. So r.contact ID. Coalesce. That's a good question. I use Coalesce all the time in SQL Server. I do not believe, I don't know if Oracle, let's see real quick. And I guess while I'm looking it up, Coalesce, for those of you who don't know, and it looks like they do have it. Coalesce is, it will return the first not null value in a list, right? So if something isn't null, it will return it first. So essentially, what we could do here is we could say coalesce r.rental ID, rental s1.nextVal, and it would theoretically produce the same results. The difference is this one only takes 2 parameters. A coalesce could have many. So yeah, I use coalesce a lot for addresses because some people might not have like a PO box, so you can or a line 2 or whatever, so you can coalesce things to basically skip those null value fields. Good question. Okay, so we have our contact ID, and then we have checkout date. So we're going to say r.checkout date. Then we're going to say r.return date, r.created by, r.creation date, r.last updated by, I always got to make sure I'm doing the right thing, then r.last update date. Okay, so there is our select that we're going to kind of pull from here. And then we say from, and this is where we're going to put our query right in here. So let's take, we're going to grab everything but the semicolon. And we'll put that right in there. Like so. And then what we're going to do is we are going to call this, oh, and we don't need this order by. We're going to call this R. So now let's give this a run here. Let's see how we did. Oh, I did something wrong. And if we look here, if you remember right, how I changed mine to customer ID right here, well, that's because we need to do the same right here. So we're going to call this customer ID. Because once we do an as right here, that's what that column's referred to in the parent query. So up here, it's going to be customer ID. And we get 4,681 rows created. And then we're going to take our little count query here. And we're going to say after. And then let's give this a run. And so now you see we have 4,688 rows versus our 7 that we had previously. So that's what we should come out with, or close to. Mine might be a little weird. Yeah, so basically, so Marie asked, we just named the whole subquery R. Yeah, and actually what we did is we actually are naming, so whenever we have a select statement, so like when we take and we run this select statement, this is actually a table now. In memory, it's actually considered a table. Now it's not permanent, it's just a temporary table in RAM, but it's there for the duration that it exists. So in this case, what we're actually doing is we create this select statement and the computer runs this and it gets all this data and it's holding it in RAM. And when we give it this name R, basically for a short time, for the time that this query is existing in RAM, the computer now knows that, oh, this table is called R. So then up here, when we say, you know, select r.customer ID, it actually pulls it right from there, from the table in memory. And we could, let's say, let's only pull the first 100 rows on this table so you can see the column headers. There we go. So here you can see that we have our columns up here, and now our rental ID is full because we've done the insert. So now we're getting this in there. So basically pretend that this is the whole query. The computer now sees this table as R, and so then like r.creation date is referring to these columns right here. So it's kind of a view. Views work in the almost the same way. So really all a view is it is a select statement that we've stored permanently, and every time you look at that view, that's what you get. So I guess just as a demonstration, because it's kind of a view, we could say create view we can actually create this view. So we have our view created, right? So now I can just say select everything from rental insert. And I get this, the same result set because I've now stored that query as a view. So it's very similar. The only difference is now this view actually has a name outside of RAM. But yep, very, very much the same principles behind them. So if it helps, you can think of an embedded subquery as a view, because technically we could, so in this case, I could actually say, select everything from, what did I call it? Rental insert. Yep. Where customer ID is equal to 1015. And I can do stuff like that. Now I only get the rows where customer ID is equal to 1015. But the difference is this view, they're not near performance-wise, they're not near as good, because every time I do, select everything from rental insert, it actually has to run this whole query. Those aren't stored. You can't index them. So most of the time what people do is they create views of data that's, used very frequently together, because for example, a good view would be something like select last name, first name, and telephone number. Right, this would be probably like a view that might be pretty popular. They're used a lot in analytics, because a lot of times in analytics you're so you would make something like this a view, because then we could say create view contact info as, so that way instead of writing a whole query, you can then say, select everything from contact view, or contact info, sorry. Something like that. And then the other reason why people use it a lot is because, if I'm a database administrator like I am, I can give people the right to view the views, because it's almost like pre-set up data. I can control what's in them. And like if I say update view contact info, set last name equal to, I'm not going to be able to change any of that data, which is good, because they only have access to what you give them. So that's why views are pretty popular. And when you say a temporary view, inside of a embedded subquery like what we have here, it's temporary because it only exists while the computer is executing this statement. As soon as it finishes, as soon as it reaches a semicolon, R is no more, it's done. But when we create a view like we did here, then it becomes permanent. It's an actual object until we drop it. So then I'd have to say drop view rental insert. And now it's no longer there. Do you mean that this won't run correctly without naming it? This one won't, because we are referring to it as R up here. So we have to give it a little name down here. It's just an alias. So yeah, we have to do that because we actually don't have a table name. And actually, in this case, I think it would work where they're all coming from the same one. But best practice, usually just name them because it's pretty rare you'd actually just use one. Yeah, and it might not based on how. Yeah, with the if you have the R's up here, so if you took off the name here and then took off these, it may work. So let's just try. And so technically this would work, but remember how I said that we would duplicate our data? Well, in this case we are, and it says unique constraint violated. So if I were to run the cleanup script first and then run this, which I should. So let's save this and let's actually run. Because that'll clean everything up, right? It'll clean everything up and rebuild it. So you can see that that did work because we only have one from clause and all of our rows are named correctly. It should work because we only have one. So it doesn't need the alias, similar as if we were going to say, select last name, first name from contact. But I like to have them just for readability. So. All right, so let's move on. So if we look here at step 2, it says the second select statement uses a query that relies on the combination of, basically what we've gone through before. But on this one, we're going to go to rental item. And again, we get this nice little select statement here that's there. Now, the important part is, it says you inserted rows into the rental table in the first step of this lab. In the second step, insert into rental item. This one says you do not need to use a distinct operator because the select list returns a unique set. So if you notice on this one, we did select distinct. And the reason we did that is because inside transaction upload, we have every item, right? So if I were to do describe, or sorry, if we transaction upload is what I meant to say. If we did describe transaction upload, you notice that we have like the item type and the item ID, right? So let's say I go to the movie store and I rent 3 movies. Well, in transaction upload, there's going to be 3 rows, but it was one rental. So we use distinct on the rental one because that's going to consolidate those 3 records for each item into one, right? Because the checkout date's going to be the same, the return date's going to be the same, first name, last name, middle name, and account number's all going to be the same. The only thing that changes is like the item specific stuff. But for rental, we didn't want any of that. We only wanted one rental for all those. So that's why we say select distinct, because if I have multiple movies all in the same rental, it's going to combine those into one row because they're all the same. So select distinct returns one unique row. And that's why we use it there. But in step 2, we're inserting into rental item. So we actually want all 3 of those rows. And because we have item ID and those kind of things involved, then we can select and just get a unique set because that unique set includes the item information. Does that make sense to everybody? The whole distinct thing and how we need it in step 1 and we don't need it in step 2? Or is it shaky for anyone? All right, I'm not getting much feedback, so hopefully that makes sense to everybody. But because, I mean, and I guess just to reiterate, and sorry if I'm beating a dead horse, but rental, if we look at the relationship between rental and rental item, one rental could potentially have many rental items, and transaction upload has all of those items in there. And so we want one record for all 5 of the movies that Harry Potter rented that one day. And so that's why we use select distinct, because it will only select the unique information in our select statement, which was like Harry Potter's name, essentially, and the checkout and return dates. So all 5 of those movies that were rented all have the same checkout and return dates, and they all have the same renter. So then it becomes one rental when we use the distinct clause. For rental item, though, we want all 5 of those rows, so we're not going to use it. Even though technically we could still put it in there, but it's going to be the same either way. So let's go into step 2 again. So now this one, we actually can use our join that we already have. Like I said, they're going to kind of build on each other. So a lot of our data is actually going to be the same. So it says join the result set from the first query solution of this lab's first step to the common lookup table. And what that means is we're going to take and I'm just going to take this from clause right here and this stuff, and I'm actually going to pull it out of this. We're going to take this right here, and I'm going to copy this. We're going to come down here, and we're going to paste it. And then I'm going to come up here on our lab help and copy our right here, and I'm going to get our select list. And then I always like to take a look and see what we have. So we have a rental item, rental, which we already have, transaction upload we already have, rental we already have. So the really only new piece of data we're adding is our rental item ID, and then our common lookup ID for the rental item type. So we know once we do our 2 joins that it should run fine. So we're going to look at our instructions here again, try to keep them up over here. So we are going to affect the join between a suitable column in the common lookup table rather than a join. You need to affect the join between a subtable. So it says you need to affect the join between a subtable inside common lookup rather than a join to the common lookup table. And it says this type of join behavior is known as translating a join. So as we know, common lookup kind of doesn't really hold, it kind of holds like containerish values for other tables. So like in this case, we're going to do a join, but we're actually going to need to specify a few extra things. So let's go ahead and build that all out. So we're going to take, and right after our last join, we're going to say, because now we're joining to common lookup. So we're going to say inner join, common lookup. We're going to call it CL1. And we're going to join that on CL1.commonLookupTable is equal to rental underscore item. And this is where we're kind of doing our translation here, because there's not a key between these 2 tables. Rental item type. And what they mean by this, so like if I were to say select distinct, because what do we have in transaction upload? We're looking for rental item type, right? So if we were to just wanted to see what kind of values we have in there, we look at rental item type from transaction upload. And oh, we have 3-day rentals, but you'll notice that that's all in text. And so that's what we actually have to look for. So if we look at this 3-day rental here, that's where we need to map to. So then if we go look at common lookup, select everything from common lookup, and we know that it's where common lookup table is equal to rental item. Here we get our stuff, and we notice that these are all capitalized, so that's what we need to do. So the lookup type is equal to the rental item type. So CO1 dot common lookup type is equal to TU dot rental item type. All right, and that is our join to rental item, or to the common lookup table, because we need that data in order to get there. So now what we need to do is we just need to do our last join to rental item. So then we say left join rental item RI. And the reason we do a left join is because we are inserting data, and we want to show it whether it's new or whether it already exists, just like we talked about before. So we want to make sure we have everything, meaning left. Left is everything that's above this. So we want everything that's here, regardless of whether or not it has a join, because right now we wouldn't have it. So, and we do that where r dot rental ID is equal to ri dot rental ID, because we've already joined to our R, and so that's the only common denominator between the two tables. So let's give this a shot. Oh, and I did something wrong. So I have cl.common lookup ID, and I called this cl1.common lookup ID. So let's add a 1 here. And oh, I like to see those records fly. You'll notice we get significantly more this time. We get 11,520 rows, which is what we want, right? Okay, and now because we don't have that distinct clause on this one to do our insert, we can actually just say, we don't have to do that little middle piece. We can just say insert into rental item, and then we can just go ahead and put our query in here. But just like before, if they have a rental ID, we need to be able to specify, if they don't have a rental ID, we need to be able to specify that we want to create one for them. So on this first one, we say NVL ri.rental item ID. If it's null, we want our rental item s1.next val. And then we can actually run that just like this. Let's get rid of the empty space there. Let's add our semicolon. Oh, and it looks like I have something wrong. So if you try to do this, and you'll notice it says expected date got number, that means that I tried to put a number where a date should go. So if I do describe rental item, because I didn't specify my column list, it's expecting these in the order it is. So rental item ID, rental ID, item ID, and then created by. So you can see things get out of whack there just a little bit. So there's two ways you can fix it. You can change the way they're ordered here, or you can simply specify the order that you want them in. So we're going to say rental item ID, rental ID, item ID. Then we have rental item price. Then we have rental item type. Then we have created by, creation date, last update by, last update date. All right, so we're just going to put our column in a list there, so that, because our order is different from what's here, right? If you look right here, you know, our rental item price is down here, but because our ordering in our query is different, that's how we're going to tell it that we put it in a different order. So let's copy this, make sure it works, and we got something else that's wrong. So let's take a look at this. So now it says FK rental item 4 violated, and our parent key wasn't found. And if we were to go look, rental item 4 is our created by. So if I were to do select everything from system user, oh, I don't have a 1001. I have 1, 2, 3, 4. So let's just change these to ones and try again. And now I get command not properly ended because it looks like I'm missing something. This is where formatting's nice because then you can see what you're doing. Okay, and when it says that it's not properly ended, usually that means that we're missing something somewhere. Just real quick, let's see. Select, insert into. Because we have our select list now, our column list, we actually don't need to have that wrapped up. And there we go. And then we get it made. And so if we were to go look, and I am not going to do the last one, but if we were to go look at it, you will find that it's very similar, except for this time you're going to do a group by. Okay, and this is kind of going to be the challenge because, I mean, we just did the first two, right? But this last one, you use you use a sum function. And what the sum function does is it's going to add all these records together. It's going to take the sum of the transaction amounts and it's going to put them, basically we're going to take how much each movie costs. We're going to add tax. That's why it says divide, or we're going to subtract tax. That's why it's divide by 1.06. And then we're going to sum that all up. And then that's how much our transaction is going to be. So I'm going to let you guys take care of that. But just so you know, the sum function, when you do the sum function, you have to have a group by clause. And he has the group by clause for you here. It's actually just everything that you want to group by. So pretty much rule of thumb is that in the group by clause, you have everything besides the sum function, which can really get messy. But anyways, most of it's there for you. The only difference is that all you have to do is just build your from clause with your where clause as well. So your from clause and your where clause you have to build. But if we look here, it'll say join the results set from the first query. So this one, you're actually going to go back up to your step one. You're going to go clear back up to step one, and I would take this, and that would be my starting point for step 3. You're going to take that there, and then we're going to go to this, and we're going to grab our select clause, put it there. And then we're going to grab our group by clause. We're going to put it there. And so really all we have to do now is from here is perform a left join to transaction, or not transaction, upload to transaction. Right, because that's the last table. And it actually gives you a nice little guide here, which makes it pretty simple. You know, not pretty simple. It makes it much more simple. But basically, we've actually already done most of what it's talking about here in the first two steps. This one just, you know, is to a different table. So I will let you guys figure that out for step 3. And then once you're done, that's actually the end of lab 10. And the nice thing is lab 11, having this done makes lab 11 much, much easier. So does anyone have any questions? Does that help a lot with the lab? Do you feel like you have good direction where you're going? All that fun stuff. Is there anything that you really don't understand about what we're kind of doing here? So far, everyone's being very, very quiet, which I don't know if it's a good thing or a bad thing. Okay, yeah, and you know, for the most part, really, what's nice is it's just a matter of, you know, basically replicate what we did for steps 1 and 2, and then for this last step, you just have to perform the same logic we did, you know, the same steps. You know, if it were me, what I would do is I would go, you know, and he tells you this in the blog, but you know, if we were doing this without the blog help, you know, I would go look at transaction and, you know, pull up that and then look at transaction upload. And I would find where the commonalities are. So like transaction amount, you know, we would want transaction type is there. Payment account number is probably payment account number, and payment method type. You know, find the commonalities, because that's what you're going to be using as your select statements, which we already have. But then also you need to find a way to join the existing data, which in this case is actually just going to be our in this case will be our account numbers and rental ID and transaction type and all that kind of stuff. So you might have to join on a lot to get it there, but just a couple of hints. You know, anything that's common between these two, I would join on. You know, if we have it. But to some of those, right? So like payment method type. So like if I do select distinct payment method type from transaction upload, you'll notice I get discover card. But if we look at transaction type or payment method type here in transaction where we want to end up, it's a number. And that's because there's that translation between, basically we have to go from discover card to common lookup so we have to go from transaction upload text, and then we go to common lookup where they have the text, and then we can convert that to the number that we want to store in transaction. So you'll have to do a join to common lookup for payment method type, and then you'll also have to have your join to common lookup for transaction type. So you're actually going to have two joins to common lookup. One for our transaction type, like we just kind of showed here, and then the other one for our, payment method type is this one that we just did, and then the other one for transaction type. Okay, and our transaction type you can see here too is our credit and debit, because we can reverse transactions with credit or debit, all that kind of stuff. So. All right, well, that's pretty much all I had as far as the lab goes. So are you guys feeling like you want maybe something more, or are you ready just to kind of dive in? I'm going to leave it up to you guys at this point, because we do have a little bit of time if you want to use it. If not, you guys can all just go spend some time with family and get started on the lab, work on other courses, whatever you need to do. Any consensus? Okay. Yeah, why don't we call it there, and we'll let you guys all go and do that, because we're really close to labs 13 and 14, and those are going to be really fun labs, and that's when we'll kind of do a lot of this extra stuff, and I've actually got some really fun stuff ahead. So anyways, it looks like everyone's ready to go. So yep, thank you guys for coming. Thanks for your questions. They make a big difference, and good luck this week.